So welcome back. We're going to do a few more examples on simplifying square roots. This will be lesson 4C, I believe. Yeah, 4C. Remember, the square root is said to be the inverse operation of squaring. And remember, when we talked about inverse operations, we're talking about this backwards thinking, if you will. Multiply and divide are also called inverse operations. So multiply and divide are inverse operations. For instance, 5 times 4 is 20, and if I work backwards, 20 divided by 4 would get me back to 5. So 20 divided by 4 gets me back to 5. So there's that true statement that way. So it's going to be true both ways, as a multiplication problem and backwards as a division problem. So if I have 12 divided by 3 is 4, what also has to be true then is 4 times 3 has to get me back to 12 for that to hold true. So 12 divided by 3 is 4, as long as 4 times 3 is 12. So we have that backwards thinking there. So again, we refer to those as inverse operations. So a lot of times I'll call it backwards thinking, but you'll hear the word inverse operations mentioned quite a bit. So we were saying that squaring and square root are kind of backwards thinking. So when I give you 8 squared 64, if I go backwards, the square root of 64 is back to 8. So the square root of 64 gets me back to 8. So if I want to know what the 5 squared is 25, then what I can also do is go, the square root of 25 is back to 5. And notice how we're looking at these as pairs. A perfect square has that same number twice. And the answer to a square root is just that factor one time. So when you see those two 5s inside a radical symbol, the square root symbol, that comes out as simply a 5, and that's our answer. So for every pair, we bring out just that factor by itself. So what I want to look at is 4 square root of 12. Now, the 4 is connected to the radical, the square root symbol, by using multiplication. So, but what I really need to do is simplify this 12. Simplify what's inside the radical. And again, I want to use my prime factorization strategy. So that 2, 3, 5, 7, 11 are very powerful tools. And since 12 is even, 2 goes into 12 6 times. 6 is even. 2 goes into 6 3 times. And then 3 goes into itself 1 time. So what I do is I'm going to bring this 4 down times then. I'm going to rewrite 12 as 2 times 2 times 3. And what I'm looking for is a pair. And I do have a pair. If I didn't have a pair, I wouldn't be doing anything. But since we do have a pair, since I have a pair of 2's, what this tells me to do is I can bring a 2 out 1 time. So I have a 2 times a 4 on the outside and have that 3 left over on the inside. So all I got to do now is put that 2 times 4 together, 8 square root of 3, and that would be our answer to that problem. So that's what we mean by simplifying square roots, is pulling out these perfect squares. So if I look at this problem, I have 8 times the square root of 105. Again, I want to simplify that 405. So I have this 405 here. I look at it, I'm using that 2, 3, 5 strategy. I don't think 2 works, but what about 3? A trick for 3's is if you add these digits together, if they're divisible by 3, then the number itself is divisible by 3. So if I had 4 plus 0 plus 5, 4 plus 0 plus 5 would be 9. Since 9 is divisible by 3, that tells me that 405 is divisible by 3. So if I divide 3 into 405, so 3 goes into 4 1 time. 3 goes to 10 3 times. And 3 goes to 15 5 times. And so it does go evenly like it's supposed to. So 3 goes into 135. Oh, I'm sorry. 3 goes into 405 135 times. Now if I add 1 plus 3 plus 5, 1 plus 3 is 4, plus 5 is 9. Since that's a 9, I know 3 goes in 9. That actually tells me that 135 can be divided by 3. So if I divide 135 by 3, 3 goes into 13 4 times. and 3 goes to 15 5 times. So it tells me that 3 goes into 135 45 times. And since that's a 4 and a 5, 4 plus 5 is 9, that tells me that a 3 goes into 45 15 times. And we do know that 3 goes into 15 5 times, and 5 goes into itself 1 time. Now, you also could have saw it ends in 5, and you could have pulled that 5 out, but don't forget that you have to still look for that 3. I like to just kind of stay in order 2, 3, 5, 7, and 11. So I have 8, and then I have the square root of 1, 2, 3, 4 3s, and then a 5. And remember, to simplify square roots, we're seeking out those pairs, so we're pairing them up. For every pair, that tells me I can bring it out 1 time. So that pair of 3s brings out a 3, that pair of 3s brings out a 3, that 8 was already out there, and I'm left over with this 5. So I have 3 times 3, which is 9, 9 times 8 is 72, I have then 72 square root of 5, and that would be the simplified version of that answer. Okay? So I hope you find those examples helpful. Stay tuned.